everyone, it's time for our third and final lesson on the Pythagorean theorem. This time we're going to look at applications, and you're going to learn to hate this word in your math student time at this school because application means word problems. So we're going to do some word problems that require the Pythagorean theorem to solve them. So let's get right to it. The first one says Rabina travels 4 kilometers north, 3 kilometers east, 2 kilometers south, 5 kilometers east, 4 kilometers north. How far is she from her starting point at this point? So hopefully you know that we've got north, east, south, west, right? Never eat soggy wieners, or whatever way you have of memorizing this. So let's see here. She is going to start at a certain point. Let's say she's starting right here. And then she is going to move up 4 kilometers. So I'm going to move up a certain amount. Then she's going east, so that's to the right, a little bit less. Doesn't matter, we don't have to nail it or anything, but a little bit less. 2 kilometers south, so she's coming back down about half the amount that she went up, so somewhere around there. 5 kilometers east, so fair bit out this direction. And then 4 kilometers north, so something like that. So she now finds herself way up here. And what the question is, we want to know, what is this distance from here to here? I'll make it a different color. Okay, now that's pretty weird, isn't it? It doesn't really look like a triangle at all. But there actually is a triangle. Do you see it? I could draw a triangle down here to here and across to there. And again, I'll make that a different color so it's easier to see. Okay, and nice, you can see that it is a right triangle. So, do we know anything about this triangle? Well, actually we do. Let's fill in all the numbers. Remember, she went 4 north, 3 east, 2 south, 5 east, and then 4 north. That 4 is from here to here, right? This amount right here is 4. Well, do you know we can actually figure out this amount here as well? How much is that? Well, look, this whole amount from here to here is 4, and this amount right here is equal to the amount we're interested in, and this amount here is 2. From here, I'll do a different color here, from here to here is 2, isn't it? Well, if that purple amount's 2, and the whole amount is 4, how much must the blue amount be? That blue amount must also be 2. 2 plus 2 is 4. Well, wait a minute, this blue amount is equal to this blue amount here, so this is also 2 over here. Okay, what about the bottom? Well, I can see that from here over to here is the same as right here. This is 5. And I can see from here over to here is the same as this amount up here. It's equal to 3. Well, great. Now we can see we actually have a right triangle where we know 2 of the legs. Right? So I'm going to redraw this triangle right here. I'll draw it over here. Okay, there we go. I've made it pretty well exactly the same size. Again, it doesn't have to be the same size, but just so it's easier to understand. And this is supposed to be the same triangle, so it's a right triangle again. How long is this leg from here to here? Well, it's the 3 plus the 5, it's 8. And how long is this leg here? It's the 4 plus the 2, it's 6. And what we want to know is how far. Remember, we're trying to find this red distance right here, which is the hypotenuse. This is what we're trying to find. I'll call it C, since we often call the hypotenuse C. And then that's all we have to figure out, is how much is that? Well, we're going to use our Pythagorean theorem. Are we going to square these two numbers and add them, or square these two numbers and subtract? Well, we're looking for the hypotenuse. We're looking for the biggest side, so we need bigger numbers than this. We better add. So we're going to do 8 squared plus 6 squared equals c squared. Turns out this is a really famous one. This is a Pythagorean triple, because 8 squared is 8 times 8, which is 64. 6 squared is 6 times 6, which is 36, still equals c squared. 64 plus 36 is 100, equals c squared. And then we have to undo that squared, right? We've got to take the square root of both sides, and it works out perfectly. As I said, it's a Pythagorean triple. That side must be 10. The hypotenuse is 10. We did it. 10 what, centimeters or something? No, not centimeters. We're talking about someone walking. Kilometers. 10 kilometers. She walked 10 kilometers. Wow, it's a good walk. Good for her. Actually, she walked further than that, didn't she? She is that far away, but she walked 4, 7, 9, 14, 18 kilometers. Wow, what a fit person. All right, the next one. The hypotenuse of a right triangle is 25 centimeters and one leg is 7 centimeters. Find the area of the triangle. Well, in order to do this, you need to know what the formula is for an area of a triangle, and I've never covered that with you. I don't know if you know the area of a triangle, but it equals base times height divided by 2. So I'll talk about that more in a second. So let me draw a triangle again. It says it's a right triangle. It tells me the hypotenuse is 25, and it tells me that one leg is 7. It doesn't matter, it doesn't tell me, so it doesn't matter where I put it. I can put it on either one. Where do you want to put it? I'll put it down here, 7. Okay, now area. First of all, you know what they're talking about when they talk about area? Area is kind of like how much does this cover? If you were to lay this triangle on a table, how much cover does it have, right? And the formula is base times height divided by 2, or if you want, 1/2 times base times height. I find most people like this version of it easier. So base is like the bottom. So the base is 7. Here's your base. Base equals 7. Height. This is not the height. Height is from the highest point straight down. This is the height. This is what we need. How are we going to do it? Well, look, they give us the hypotenuse. They give us one leg, which happens to be the base. We can get the other one by using the Pythagorean theorem. You knew you were going to use the Pythagorean theorem, so let's do it. Now, we're going to square both these numbers as we always do. Are we going to add or subtract? We got to subtract this time because we know the hypotenuse. We know the longest side. So we're going to do 25 squared minus 7 squared equals a squared or b squared, whatever you want to call it. I'll call it a squared. 25 times 25 is 625. 7 times 7 is 49. That equals a squared. So now we're going to subtract 625 minus 49, and we get, whoops, that should say equals. We get 576 equals a squared. And as always, our last step is to take the square root. I believe we have another Pythagorean triple, all these nice whole numbers here. The square root of 576 is 24. So 24 equals a. Now, I know that feels good to get the answer, but remember, you're not done. All you've found so far is that the height is 24. But we want to find the area of this triangle. So remember how to do it? It says right here, area equals b times h, that's base times height, divided by 2. Well, what's the base? We already said that. The base is 7. And what's the height? The height's right here. It's 24. We just found that, and we have to divide by 2. So 7 times 24 is 168, and then we divide it by 2, and you'll get that the area is 84, and it's centimeters. When you talk about area, it's centimeters squared. You got to put the little squared on it. So right there, and that's your answer. Okay, so all these questions using the Pythagorean theorem to answer word problems. Let's keep going. Oh, here's a classic, the ladder placed against a wall. Now, the reason I like being a math teacher is because your drawings can be really, really, really straightforward. Here's the wall. It has to be some ground for the wall to sit on, and then we have a ladder being placed against the wall. There you go, that's my drawing. Don't do anything fancy, okay? Now, what's going to obviously pop up with all your drawings today? Right triangles. It says a 10-foot long ladder. Which one of these is the ladder? Here's the ladder, it's leaning up against the wall. So this is 10 feet long. The bottom of the ladder is 2 feet from the base, so this is 2 from here to here. Why don't I just get rid of the rest of this line, because we don't need it. So I'll shorten this up. That's 2. I don't need this extra part up here either. There you go. Now I have an even easier picture to look at. So the bottom of the ladder is 2 feet from the base, right here. Base is the bottom of the wall, right? So it's 2 feet. How high does the ladder reach up the wall? So what we want to know is, what is this distance right here? This is our unknown. I'll put, I don't know, I'll put x. Well, we got a right triangle where we know two sides. You know you're going to use the Pythagorean theorem. You're going to square them both, and you're going to add or subtract. We know the hypotenuse, so you're going to subtract. 10 squared minus 2 squared equals a squared or b squared, or since it's x, I'm going to put x squared. 10 times 10 is 100. 2 times 2 is 4 equals x squared. Subtract there, you get 96 equals x squared. Last thing you always do is take the square root. So you need to figure out what the square root is of 96. And you get 9.8 if you round it. You get 9.8. 9.8 feet, I guess. We're talking about feet. So that is how far up the wall this ladder reaches. Okay, last one. A square has an area of 144 centimeters squared. What's the length of the diagonal of the square? Alright, more area. So let me draw a square first. There we go. And it says the area is 144 centimeters. Now, how do you get the area of a square? The area of a square is the same as a rectangle. It's length times width. But here's the thing. If we look at a square, what do you know about the length and the width? They're the same as each other, right? So what we actually often call them is not length and width. We call them side and side. We call all of them side if you want. Each one of them is a side. That's not 5. That's side, side, side. So if we want to get the area of a square, yeah, you could do length times width. But you could also go length, side, which is S, times width, which is also S. Side times side. Side times side. Well, wait a minute. What's a faster way of saying side times side? How about side squared? This is really the best formula for the area of a square. Now, why is that helpful? Because it tells us that the square has an area of 144. We know the area. We know what this big A is. The big A is 144. And what we want to find, well, ultimately, actually I've kind of jumped ahead here. Ultimately, what we want to find is the length of the diagonal. You might not even know what the diagonal is yet. Well, I'll get there in a second. I'm sorry, I'm not doing a good job with this one. But why don't we find the length of the sides first? So we have that 144 for the area equals side squared. Oh, darn, I don't want it to be side squared. I want it to just be side. Well, doesn't this look a lot like the last step in the Pythagorean theorem? What do we do to get rid of the squared? We unsquare it. We take the square root of both sides. So the square root of 144 is 12. And if we square something and square root, they cancel out. You're just left with S. Great. So now what I know for all the sides of this square, they have side lengths of 12 all the way around. I'll just label 2 of them. And I'll get rid of this 144. We don't need it anymore. Now, that's not what the question's asking. The question's asking what's the length of the diagonal. And you might not even know what the diagonal is. I'm sorry, I should have told you at the start. The diagonal is from one corner to the opposite corner. So that's the diagonal. There's another one here, right? From here to here. But you only need to worry about one. They're equal to each other. So as long as you find one, you found them both. Okay, do you see what you're going to do here? Take a look just up here. And what you should notice is there is a right triangle right there. I don't think I even need to redraw it, do I? You can see it. There it is. Right angle there. We have the 2 legs, and what we want to know is how much is this amount right here, the hypotenuse. Time for the Pythagorean theorem, and you're looking for the hypotenuse. You're looking for the longest side. So we're going to square both of these 12s, both of them, 12 squared and 12 squared. And since we're looking for a bigger amount, the hypotenuse, we have to add. So 12 squared plus 12 squared equals c squared. 12 squared is 12 times 12, which is 144. So obviously, if we do it again, it's another 144, and it equals c squared. Add those up, and you get 288 equals c squared. And then the last step, whenever we do the Pythagorean theorem, is to take the square root. So we've got to take the square root of 288. And you get 16.97. Actually, it rounds to 17. So I'm going to put that. 17. Is there centimeters something? Yeah, centimeters squared was the area. So since we're talking about centimeters, it'll just be centimeters for the diagonal. It rounds to 17 centimeters. Okay, that's the length of the diagonal. All right, everyone, take care. Bye.